Hello everyone, in today's video we will be continuing the previous topic. So in the last video we have studied about EM field tensor. Now we will study its counterpart, that is dual EM field tensor, that is represented by G mu nu. So let's start our video. So before starting the video, you can get your solution booklet for 2024 now. We have made an effort to provide you this solution booklet as soon as possible so you can save your time and straight get to the answers. So link is in the description box, so grab it now. So let's take a quick look what we have done in the last video. So in the previous video we have learned about covariant and contravariant tensors, and then we have defined the EM field tensor F mu nu, and then we have seen the conversion from covariant to contra and vice versa. In this video we will be deriving G mu nu, that is dual EM field tensor, using epsilon mu nu lambda rho, that is Levi-Civita tensor, and the F mu nu, that is EM field tensor. So dual EM field tensor is an antisymmetric. Antisymmetric means that its G mu nu is minus of G nu mu, and this pseudo means it does not follow the strict transformation rules. Let's define this using the EM field tensor. It can be defined as G mu nu in its covariant form is given by minus half epsilon mu nu lambda rho F lambda rho. This is in contravariant form, and this we know Levi-Civita tensor of rank 4. So let's see the Levi-Civita tensor. This can be defined as epsilon mu nu lambda rho is equal to, this can take +1 value, -1 and 0. Even permutation or swaps, value will be +1. For odd permutation will be -1, and otherwise it will be 0. So what this even permutation, odd permutation means, so let's understand it. And we know that for the ordered indices the epsilon value is 1. So if we want to find the value for 0, 3, 1, 2, so we have to make some swaps to get the indices in order. So let's see, we first have to swap this 1 and 3, and then we will get epsilon 0, 1, 3, 2, and then we swap these two, then we will get epsilon 0, 1, 2, 3. So we have to make the two swaps to get the indices in order. So that means it is even permutation. We require even number of swaps. So that means the value of 0, 3, 1, 2 is +1. Similarly, let's take another example, epsilon 3, 0, 1, 2. Let's see the value for this. We will swap 0 and 3. So this is the first, and then we will swap these two, 1 and 3, 0, 1, 3, 2, and then we will swap these two, epsilon 0, 1, 2, 3. We will need 3 swaps, odd number of swaps, to get the indices in order. So this epsilon 3, 0, 1, 2 will be -1. So this is how we will use this whole function. So let's move to the dual EM field tensor. Let's derive its elements. So we can write G0I as using the equation. What is the equation? G mu nu is equal to -12 epsilon mu nu lambda rho, and this is lambda rho. We are just finding for G0I. So this will be 0I jk, and this is f jk, where the indices jk will not take the values as 0 or I. Let's take I is equal to 1. So we are finding 0, 1 element. So this will be -12 epsilon 0, 1 jk f jk. So now j and k can take values 2 and 3 only. -12 epsilon 0, 1, 2, 3 f 2 3 plus epsilon 0 1 3 2. So these are the two possibilities, and we know this value as plus 1. We have to do only one swap. This will become 0 1 2 3. So that will be minus 1. That is odd permutation. So the value for 0 1 3 2 will be minus 1. And we know that f23 is minus of f32. So we get G01 as minus half. This is plus 1. This is f23 minus of f23. We can write f32 as minus of f23. So this is half twice of f23. We can cancel this 2. So we get minus f23. So now let's take a look at the EM field tensor f mu nu to get this f23 element. This is f mu nu. This is 0 1 2 3 and this 0 1 2 3 rows and columns. So we want f23. So f second row third, this is minus bx. So our G01, which is equal to minus 2 3, will be minus of minus bx. This is bx. Similarly, you can find for G02, that would be equal to by, and G03, that would be equal to bz. We can generalize this. We can write bx to be b1, by to be b2, and this bz to be b3. So we can generalize with an equation. So G0I element is equal to bi. This is equation number 1. We found out these 6 elements, that is G01, 02, 03, and a 2 antisymmetric property. We have also find out 30, 20, and 10, and the diagonal elements 00, 11, 22, and this 33 will be 0 because of the Levi-Civita tensor. So we found out the 4 and 6, 10 elements, and we know it's a 4 cross 4 element matrix. So we are left with 6 more, and so we have to find out 3 more and then use the antisymmetric property there also. So let's find the other elements, the space like elements now. So Gij is equal to minus half epsilon I j k l f k l, where I and j are not equal to 0. So let's sum up the possibilities. Epsilon I j k 0, f k 0 plus epsilon I j 0k and f 0k. So these are the two possibilities where k is not equal to I and j. We can write this as minus of epsilon. We can swap these two and then these two and then these. So we get minus of epsilon I j k, because we are doing the 3 swaps. So we are taking the negative sign here. fk0, then this is epsilon, swapping this, these two and these two. So these are even number of swaps. So this is 0 ijk f0k. We can write epsilon 0 ijk as epsilon ijk also, where ij and k are not equal to 0. So let's take the epsilon part out. So this is minus half epsilon ijk. This is minus fk0 and f0k, and we know that fk0 is minus f0k. So using this, we will get half epsilon ijk. There will be twice f0k, and this is 2 will cancel. We will get minus epsilon ijk f0k. We got the generalized equation. So these are the f0k elements here. You can see. So we can generalize this as minus ek by c. We will get minus epsilon ijk, and this will be minus ek by c. So we get the generalized equation as Gij is equal to epsilon ijk ek by c. So let's use this and find the elements. Let's find G12, epsilon 1, 2, and this will be 3. This is E3 by C. So this is the ordered epsilon. So this will be plus 1. E3 is EZ by C. So this is our first element. G21 will be minus of EZ by C. Similarly, we can find G13 epsilon 132 E2 by C. So we will need one swap. So this will be odd number of swaps. So this will minus 1. And this is E2 is EY by C. So this is minus EY by C. So G31 will be EY by C. Let's see another element, G23. So this is epsilon 231. So we will need one swap and this two swap. And this is E1 by C. So this is positive 1 and this is EX by C. So this is EX by C and this 32 will be minus EX by C. Let's write the matrix now. E mu nu. So let's write the diagonal elements to be 0 first. And we know the time-like and space-like elements. So this is, so G01 is Bx. This is Bx, By and Bz. Similarly, we can write with the negative sign minus Bx, minus By and minus Bz. So G12 will be Ez by C and this 1,3 will be minus Ey by Z and this 2,3 will be Ex by Z and this is antisymmetric counterparts and this is Ey by Z. So this is our covariant dual EM field tensor. So let's compare F mu nu and G mu nu. So this is EM field and this is dual EM field tensor. So we can get the G mu nu from F mu nu by just substituting E by C with B and minus B with E by C. So you have to replace E by C with B and this minus B with E by C. So you will get the dual EM field tensor from the F mu nu. So this is it for this video. If you have any doubts related to this video, you can write me in the comment box. If you like this video, please like, share and subscribe to my channel, and thank you for watching this video.